Hello! I wanted to put a video together about taking apart and restoring a keyboard for an SX-64. The reason I wanted to put this together, I know there is a couple of other videos out there and various guides from people who've done it before, but the reason I wanted to do this is partly because my friend and co-host on Chicken Lips Radio, Earl Evans, had pinged myself and Todd, my other co-presenter, a month or two ago, asking us if there had been, if we'd got any experience with stripping an SS64 keyboard down and taking it apart. And I thought when he'd asked that question that that I'd done it before, because I own 3 SX64s. And I thought I'd stripped the keyboards down in the past, but when I had a quick look around and looked at the images and the videos, I realised that it was all new to me and I hadn't actually done it before. So I thought, as I owned 3 of them, I dug out my my own SX64s to see how the keyboards were responding, and having not been used in anger for quite some years, certainly all of them exhibited quite a lot of problems with the keyboard. So I had a crack at doing the first couple, and it wasn't without its challenges, but it was ultimately successful. So I thought for the third one, before I even started on it, I thought I'd record my experiences, and hopefully everyone else can benefit from it. The second reason I thought I'd have a go was because within a couple of weeks of the email exchange with Earl, there was a posting on the SX-64 Facebook group by Rich Meller, who runs a company, RWAP software, and he'd asked if there was any interest in getting the new keyboard membranes manufactured for the SX-64 keyboards. And I think he needed something like 50 to make it worthwhile, and I think the feedback on that particular thread was indicated that 50 wasn't going to be difficult to sell, so he went ahead and had those made, and as of time of recording, which is I think the 3rd of January, I think of the 100 that he put up on his shop, which I'll put a link to below, I think there's currently only 20 left in that first batch. And the final reason why I decided to do this was, again, on the Facebook groups, there was still a few people making posts about the challenges they'd had with restoring their own keyboards and asking questions about how to go about it. So again, based on my experiences of doing the first 2, I just wanted to pull all of that together with some of the tips and do's and don'ts and potential downfalls. Okay, so this is how a good condition SX64 keyboard should respond. Every key should have a nice positive action. There should be no skipping, no bouncing, and in fact, on a good conditioned keyboard, the key shouldn't even need to move the full travel. Just a very light touch on the key should be enough to get it to respond. So this is the keyboard that we're going to be working on, and as you can see from this one, the response is much worse. If you press the 2, you can just about get it to respond, but most of the other keys you can get nothing from, even if you press them quite hard. In fact, I think, oh, hang on, we get a little bit from the letter A there, but that's about it. Really nothing else is, oh, return key we can get a bit from, but yeah, this keyboard's in very poor condition. So let's take a look at the keyboard and how we go about taking it apart. The first thing to note, and as I'm sure many people will be aware of, is that the keyboards are fairly fragile in terms of the plastic used. I don't know whether it's just a feature of how Commodore made the dark coloured plastic, but certainly a lot of the dark coloured bits are very fragile and don't respond well to you know, being dropped or bashed or whatever. On the plus side, some of the parts, such as the keyboard latches here, there is people who've manufactured 3D printed parts to replace them. So to take it apart, you have to be aware of where the plastic clips are that hold it together. There's a few along the back, and again there's a few along the front. I don't know how well the camera will zoom on that, but I think there's 4. 1, 2, 3, 4. My tip for getting the keyboard apart was taken from Ray Carlson on his site, where there's a page on SX-64 keyboards, and that is to use a coin just slipped into the gap at the side of each side of the keyboard. I live in Switzerland, so this is a 10 Rappen coin, which fits in that gap there, and we should find, with a gentle twist, about 1/4 to 1/3 of the way down, it'll pop apart very easily. Let's do the same on this side. Again, 1/4 to 1/3 of the way down, a gentle twist, and you see that comes apart super easy. And there we go. That's the first part off the keyboard, and without any broken latches. To get the keyboard out of the top half or bottom half, depending on your perspective, of the keyboard shell, there's 4 screws here, 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 and here. Not this one. This one's the one that's the ground plane of the membrane connected to Earth. So we'll leave this one for the moment and just undo the other 4. And there we go. Now you should be able to just pivot it up at the front, slide it forward. You see there's metal catches, well, that slide into little recesses along here. And then we're out. And then you can see we have the ribbon cable, which is the housing for the 23-pin D connector is clamped just here. So you need to remove these 2 screws just here. Again, when you're undoing the screws in this, because the plastic is brittle, don't give it a quick sudden turn. Just apply the pressure gradually, so we don't crack the plastic. Okay. Now the keyboard is free. So the first thing we need to do is actually remove the keys from the PCB and the backplate. This is actually really straightforward. Each of the keys has a little plastic clip on either side, and just pushing the clips in towards the center is enough for the key to then pop out, and then it very simply comes out of the front like that. So we now need to work our way around the keyboard and get the other 60-something keys out. unlike on a normal 64, there's nothing special about the mechanism for the shift lock key, because the latching of the shift and the LED is all done with electronics inside the SX-64 mainboard. So although there is the LED there to show it, the key itself is just a normal key, with the difference that there's a little cutout there to allow the LED to shine up through there from the PCB. And there you can see the LED. So let's just pop the last few keys out. And lastly, the spacebar. Again, the only difference with the spacebar is that you've got 2 extra sets of latches on either side that need to be popped out. But again, these come out very easily. And then in the middle, it's just the same as the other keys. Spacebar out. And that's it. That's all the keys removed. So before we move on and start talking about actually getting the membrane off, let's just have a look at the construction of the keyboard a little bit, and one of the keys. Now hopefully this will show up on the camera. Now what you can see on the key itself, if I can catch it in the light, right, is that this circular area around here sits clamped to the keyboard and clamping the membrane between it by the latches on either side. And you can also see that there's a tiny little, let's get that a bit better. That's it. You can also see there's a tiny little raised ridge around the outside of this circular bit, and that circular bit, that round bit, is actually clamping against the membrane. The reason I'm highlighting this is because some people have issues when they they've taken great care when putting everything back together, and then when they power their SX-64 up, it powers up with one key appearing pressed when it comes up, and that key is effectively in a permanently pushed down position. And this is why it's important when we come to putting it back together, that the membrane itself is perfectly aligned. And when you take the membrane off, if you damage any of the rubber underneath it, when the center of the key pushes down, it actually pushes down on the contact, because the only bit that's actually making the connection is just the strength of that tiny spring in the middle of the key. And if you just keep your finger there and just push it, I mean, there's not a huge amount of force there at all. And it's only that spring pushing down on the center of between the clips there, and you might be able to see where it's worn slightly and where you can actually see it slightly shiny in there. It's just pushing that, the pressure of that spring in the center between the pads there is what makes the connection, and that's a tiny amount of travel there. That's why you often get problems when replacing the membrane of having a key in a permanently on position. But we can avoid that by being super careful how we take the membrane off, and then making sure that we align it well when we put it back on again. So before we start removing the membrane, there's a couple of things that we have to do first. We have to remove the screw that connects the ground plane to signal ground. The whole of this black area on here is basically a carbon film that is that's all connected to the ground. In fact, if we just stick our meter on there and have a look, let's just move that up so we're in shot. From that ground screw to the far corner of the board, you can see we have a resistance of just under 1k, 1 kilo ohm. Yeah, so just over half from corner to corner. So that's the first thing we need to remove. Put that safe with the other screws. The second thing we have to do is to remove this metal bar here, which is the clamp that connects the signal paths to the 8 signals that go to the underside of the membrane to the PCB. If you remember the basic construction of the 64 keyboard, you basically have 8 rows and 8 columns, which form a matrix of 64 intersections. And 8 of those signals go to, say, the top part, to the membrane, and 8 remain on the PCB. And this bar is what clamps the gold contacts, as we'll see shortly, in place. So let's go ahead and remove that. Just hold that in place so I can take the remainder of that screw out. Okay, put the screws safe, and there's the metal bar. It's important to remember that the which way round it goes, the little reinforcing ridge on the top actually goes on the top, so there's a little cutout there that shows you which way round it goes, like that. So now we have to tackle the most delicate part of the operation, which is removing the membrane. If I tilt this up on its side so you can see the construction of this, and just gently pull away that corner, the white area underneath is basically a thin piece of rubber. And that is basically what keeps the mylar, or whatever the plastic is that constructs it, and keeps that raised off the ground. Now, raised off the PCB. However, especially the areas surrounding where I was talking about a moment ago, where the ridge of the key pushes down hard, then over time the plastic or the rubber of the underside of this adheres to the PCB, and if we pull it off too quickly and tear that rubber, then we get the problems where when you put the key back in again, it makes a permanent contact. So this is the bit where we have to be super careful with removing it very, very slowly. Now, over the course of the last couple I've done of these, my preferred method is to use a toothpick, and then remove it very, very slowly. And when you get a bit that adheres, you use the toothpick to very gently prise it away. Now, the first couple on this keyboard have actually come apart very easily. Now, I wouldn't normally do this holding it up at this kind of angle, but I'm just trying to do that so you can see what's going on with the camera. Now, actually, on first, this one's coming apart even easier than my first two. Now, so far, none of this has stuck. Now, where it will stick, definitely, is where the clamp is holding this down. Because underneath here on the original construction of the PCB, there's a small piece of tape that has 8 double-sided contacts on there, and that just provides some thickness so that when the metal bar clamps down, it's got something to push against, that's got a little bit of give in it. So I'm now going to start removing more of the membrane until I find a bit that sticks, which I can then show to the camera. So, somewhat vexingly, this one is coming apart really, really easily. None of the rubber is really sticking, and I'm only applying the very gentlest of pressure to this. Oh, hang on, now we might have a little bit that's being a bit more challenging. Right, so it's sticking up here. So what I'm going to do is I'm just going to use the toothpick just to gently lift it free. Because what you mustn't do is tear these bits, because the bits surrounding each individual pad, that's where that outer ring on the underside of the key pushes down, and if any of that gets displaced, that's when you get problems with keys permanently in the down position. I know that some people have spent upwards of half an hour just removing this, because you have to be so careful. Now you can see now on this one just here that this one here is sticking a little bit. Yeah, I think as we're moving down the board, let's just try and zoom in a little bit more. So very nearly there. And we're off. That's it, that's the membrane out. Okay, so now the membrane is off the PCB. Let's have a closer look. I'm going to start by looking at the connector just here. So this is the little bit that I mentioned earlier on, where the signals to the membrane come through this connector here. Let's just zoom this in a little bit more. Right, and you can see already where we peeled the membrane away that there is some damage here that's going to need to be touched up. You can see where the graphite conductor has come away from the piece of paper here, and also if you look closely just here, you can see that also some of the conductor has come away from these contacts. Now that we are going to have to touch up with some conductive graphite paint. It can be particularly problematic on this side. Let's see if we can zoom in a little bit more. It can be particularly problematic on this side because the trace comes in from here, right? And if it's peeled, and if the graphite has come away right down this edge, you may not have enough of the trace left down here for which to put the graphite paint. In which case you may need to peel away a small amount of the plastic or rubber coating just here. But with this one, I think we should hopefully be okay. So the first step is going to be to get some graphite paint and just touch up the contacts here, and also on the corresponding ones on here, so that when it goes back together we get a good contact. Okay, so I'm going to repair the contacts using this remote restore, which is a keypad repair fluid for carbon keypads. Like all of these, you need to make sure it's been very well stirred. I've been stirring this for about 10 minutes. Now this one, as you can probably see, is quite a thick consistency compared to some of the other ones. For reasons I'll talk about shortly, do not use this for touching up the keypads on this, because the thickness of this when it's on here will almost certainly be thicker than the thickness of the rubber. But for the contacts to the PCB, which are going to be clamped together permanently, this should be fine. Okay, let's wait for that to dry, and meanwhile we'll do the same on the PCB side. Right, that's done. PCB side, let's just, oh, won't focus that close. Come out a little bit, there we go. So wait for both sides of that to dry, and then we'll come back and tackle the next stage. Okay, so now that's dried. Let's see what kind of resistance we get from one end to the other. So we go down these one at a time. I think that should be number one there. 57 ohms, 45 ohms, that should be okay. Number two. .25 ohms. Number three, 29, number 4, 25, number 5, 26, number 6. Oh, and in case you're wondering how I know, it's because I've got a little piece of paper just to the side of me showing me what the furthest away contact is for each one of the connections. Number 7, 23, number 8, 26, and number 9. Oh. Here we go. Come on, 40. If you're wondering why there's 9, that's because the 9th contact here is the ground connection for the restore key and the shift lock key. Oh, and when I'm probing the membrane, just be careful if you're doing that, because some of the points on the tips of multimeter probes can be very sharp and you can scratch the carbon off if you're not careful. So when I'm doing this, I'm just using the shoulder of the point where it's a lot more blunted. So to clean the pads on the membrane, I'm just going to use a cotton bud and very gently just buff the surface of each one with a clean bud. I personally think you need to be really careful using the remote repair stuff like I did on the on these connections here on these pads, because the clearance between the pad and the gold contact on the PCB, as I said before, is really small. And if you're using, for example, the brand that I was using on these, I mean, you know, if I just gently touch that, there's definite thickness to that, and I'm sure a lot of the problems many people have after they put their SX-64 keyboards together are caused by simply the thickness of the carbon contact repair stuff on top of these pads. I mean, I can see now, I mean, it just very gently rubbing it, you are lifting a tiny bit off, but as you saw when I probed this a moment ago, the resistance is very low through here. I mean, if you think that the rubber contact that you get on the underside of a plunger on say a C64 keyboard, the resistance across that carbon impregnated rubber is about usually of the order of about 50 to 100 ohms, and yet the whole trace on this from end to end is, you know, in perfect cases about 25 ohms. And I just simply don't, you know, so they're very conductive. So I think in many cases it isn't actually worn off here. I think it's just the residue on the underside of the pad. And okay, the sample size is only 2 keyboards to date, and this is the 3rd one. But so far, completely non-responsive keyboards I've restored and not had to put any of the carbon repair stuff on the underside of the membrane. Maybe when I put this one together I'll be proved wrong, but let's see. Meanwhile, I'm going to go through and just finish doing all of these. Okay, just getting to the last few. I'm rotating the cotton bud and choosing, swapping ends every 4 or 5 keys so that I know I'm using a clean bit of bud on everyone that I'm just buffing slightly. And last one. Good. Alright, so now the PCB. I can see all of my carbon where I've touched up the pad here. I'm just removing some little bits of excess carbon that I've inadvertently got on the PCB around there. And then let's just check that we've got good continuity from that. So again, let's get the multimeter. Set that up so you can see the reading. Okay. So, the first one. 5 ohms, perfect. Now 1.8 ohms. I don't think we're going to have any problems here. One and a half ohms. 3 ohms. 2.3 ohms. 2 ohms. 4.4. 1.9. 2. Perfect. Right. Okay, so to clean the PCB, I'm just going to use some low lint tissue in some 95% isopropyl alcohol. When you do this, be very careful not to get it on the bit that you've just cleaned. Sorry, that you've just touched up, because this will probably end up removing it again. So just work methodically over each of the pads. And you can see there's this bit of discoloration on there, so there's definitely some muck coming off here. Okay, then what I do for a second time over the board is I use some contact cleaner. My theory on this is that the alcohol removes any kind of greasy residues which you often get as in keyboards, depending on the environment that they've been in. And I use the contact cleaner, which evaporates very quickly, to remove any other oxidation. I mean, these contacts are gold, so theoretically you shouldn't get any oxidation on these, but how much of a difference this second pass through actually makes, I don't know. But I've always done it on keyboard PCBs and never had any problems as a result. Okay, so now we have a visual inspection of the board. Make sure we haven't got any little bits of lint from the tissue or anything else like that. Get the air duster. Now we do the same for the membrane. Now I'm going to lay this back over the top of the PCB. We're not ready to reassemble now, but we'll while that's clean, with a bit of luck, that won't have to come off again. I'll worry about getting it perfectly aligned when we've taken a look at the keys, but let's just place that over the top like that and put that safely to one side. Okay, so for cleaning the keys themselves, let's just wait for the camera to focus there. What we basically need to check is that the spring is properly has not been compressed. You can see when you hold that, if I hold that perpendicular to the camera, you can see just a slight bit of pressure in the spring appears. If the spring has been compressed too much through overuse, what you'll see is that the spring is quite recessed into that. It should be in the perfect position, just slightly below flush with the surface of the key. If you do have ones where the spring has been compressed and is quite far down, you can, if you're super careful, just extend this very slightly. Right, so let's move that out of the way, and maybe, and by putting a little bit of pressure and just extending it just a little bit. You've got to be really careful not to overdo that though, because if you overstretch the spring, then you create the opposite problem, where the spring sits proud of the surface. You can see on this one now, you can see it's just below the surface there. So just a tiny bit, and then the spring begins to appear, which is about perfect. If you do have ones that have do sit slightly proud, I don't actually, this one I think just needs pushing down. You can just use the tip of a fine screwdriver, and in fact sometimes the spring actually sits on, I don't know whether you'll be able to see that inside there. You can just see it sits on that little pin in the middle of the key. That's a fairly easy fit over there, so normally just the pressure of your finger will be enough to push it down over the pin. But if you have one where the spring sits proud, it may be that it just isn't sat over the pin correctly. If you get that, then just get a small screwdriver, apply a bit of gentle pressure and just rotate clockwise, and that should be enough just to push the spring over the end of the pin. So now I'm going to go through all of the keys one by one and check that the springs are sitting in the correct position, and where necessary I'll stretch the springs a tiny bit. I won't record all of that because it won't really be very interesting, and I'll come back to you when that's done. So now let's start putting everything back together. I'm going to start by getting the membrane aligned on the PCB as best as I'm able. I'm going to start in the top right hand corner where the F1 key is. Now one thing I'm going to have to be careful of here is getting this just needs to go just under the edge of these clips like that. Okay, good. Right, now I'm grabbing it in the opposite corner so I can maneuver it around a little bit better. I'm going to want to get this as perfect as I can on those holes. Let's come. There we go. I really want to get these centered exactly as I can. And then when I've got the F1 key, I'm going to go down to the opposite corner of the board and try. There we go. I think that's about perfect. Okay. I think across the board there. Yeah, still needs to come just across a little bit, I think. almost like that they almost expand slightly because I can't get it completely exact. Not far off, but not exact either. I think what I have now is probably the best compromise. Okay. Just go up a tiny bit on this end. Right. Okay, I think I'm happy with that. So now I've got this aligned, I'm going to put a few of the keys in place first of all before I clamp the bar down. Now I've got a particular subset of keys I'm going to use. F1, ST, V, 9P, semicolon 2 and the shift lock. Reason I've chosen these is because that combination of keys will test all of the possible all of the signal lines, both on the rows and the columns on the PCB and on the membrane. Right, let's start mounting the keys. They go in super easy. Just place them in, click. That's all there is to it. Let's try and get the ones in opposite sides, just so we hold the membrane in place as best we can. Now, even just doing that, the membrane has moved a little bit annoyingly, so let's just try and pull that back into the ideal place. There we go. Alright, shift lock. And once you've got the first few in, the membrane really shouldn't then move very much. Right, that's our first 9 keys back in. Now let's put the clamp back over the top. Remember that the ridge, you can see in the light there, goes on the top, and the shaped cutout goes at the top of the top. Right. And the screws go in from underneath. In place. And although not needed for our initial test, we'll take this opportunity to put the ground screw back in. Be careful tightening that because it does have a habit of grabbing and twisting that slightly, so don't over tighten it and tear the membrane. Okay. Right, let's plug this into a SX-64 and see what kind of response we're getting. Alright, so we've got the keyboard plugged into the SX-64 with the first 9 keys in place. Let's just turn it on and just wait for that to power up. There we go, and we first see that no keys have appeared, so we don't have any stuck keys. When my able assistant zooms in on the screen, we should see that, yeah, nice light presses on all of those keys. And the shift lock key. Yeah, looks like we have a good repair so far. Okay, now just the last couple of keys, and then we can give it a test. Okay, all done. Okay, now we've got the keyboard fully back together. Let's see how it tests out. Wait for the screen to come up. Let's go through all the keys. Delete. Yeah. Control. Flip back to blue. Only the very lightest of touches is now required on the keys. See, shift lock key works. First the keys, spacebar, finally, one-stop restore. Perfect. Okay, so putting the keyboard back in its shell is super easy. First we need to clamp the cable down. Just beware that the screws for holding the cable are just a little bit longer than the ones that hold the keyboard down into the base itself. Okay, let's be careful not to over tighten them. Now these metal tabs have to slide into little recesses at the back. Okay. Now we have 4 screws to go back in, here, here, here and here. Okay, now just to clip the front on. And across the front. Okay, that's all done.